friends, welcome back to my channel. In this session we will troubleshoot and we will see how we can check, test, verify this SMPS section. This power supply section is using STR IC 3A155D, that is 8-pin IC. This is its sample circuit. Now if you see the configuration of the circuit, pin 1, that is source pin and overcurrent protection, and here is R overcurrent protection, this is current sensor resistor. Then VCC pin, after that ground. Then feedback and overload protection. Feedback is received from optocoupler primary side, that is connected at secondary side. It will give feedback to provide regulated voltage. 5, 6, 7, 8. These are drain pins and startup pins. Initially it will provide startup current from this pin. When it will start switching, then we will receive voltage from auxiliary winding. 3A155D can provide maximum 35 watt power output, and it have auto restart function. Maximum peak current, that is pulse current, that is 7.2 ampere. Startup voltage 15.3 volt and UVLO 8.1 volt. Operation stop voltage, that is the bottom level of the VCC voltage. Switching frequency 67 kHz. Then there are voltage limits for feedback and current limits. On state resistance RDS on is 1.1 ohm in case of STR155. Here is pin out. Pin 1, MOSFET source pin and input of overcurrent protection, as we discussed here. Pin 2 is supply voltage and also for over voltage protection. When the voltage will increase than the rated voltage, this IC will become to know that output voltage are going above than its rated limit. Pin 3 ground. Pin 4 feedback and overload protection. 5, 6, 7, 8 MOSFET drain and input for startup current. Initially it will take startup current from here and it will provide biasing to its internal circuit. When it will start switching, this MOSFET pin 1 is connected to current sensor resistor. It will start switching. When it will start switching, then it will receive voltage from this auxiliary winding. So its startup circuit is built in. Let's see how we can fix it, how we can test it. First I will replace this capacitor. It is 35 volt 470 microfarad. It is 105 degrees centigrade. I will use normal capacitor, 35 volt 470 microfarad. It is 85 degrees centigrade. Because this time I am doing experiment. When we are replacing, always take care for the temperature. Here all capacitors are 105 degrees centigrade. When we are correcting capacitor, always take care for the polarity. This white marking, it is a negative marking, that this pole is negative pole. Here is negative pole. I will install 105 degree centigrade capacitor. But now for just only test purpose, for experiment, I am using 85 degree centigrade capacitor. We need to replace the same temperature rating, otherwise this capacitor will damage quickly because its temperature will increase and it will damage. Set multimeter to capacitance. Discharge the capacitor. 29.7 microfarad. For the time purpose I am installing this capacitor, but we need to replace it because its capacitance is less than its tolerance. If we check, this circuit is totally separate from the other board. From here until here it is separated. Input terminal, fuse, then this circuit, it is connected here. So that means it is interlock. These resistors, these are connected here to drive this transistor. It will drive this relay. That means this is the most important section for this board, that this power must be present, then this network will active. EMI protection, then NTC, after that we have bridge rectifier, voltage will provide DC here, then we will receive voltage at this transformer. So now we will check the function of this circuit, and here is feedback network, this optocoupler. Now we will apply power and we will check it. I will apply power using series lamp. AC voltage at the input of bridge rectifier, AC voltage. DC voltage 210 volt. That's not good. 230 volt here inputs. 231 multiply with 1.414, it must be around 325 volt, but it is providing just only 210 volt. That means there is something wrong. We need to verify this section now. Here, this capacitor area, bridge rectifier. Verify voltage on this capacitor before touching to the board. First we will verify the bridge rectifier. Connect black lead to one terminal, output terminal here. Check with input point. Okay. Okay. Reverse the leads. Okay. Okay. Move lead to second terminal. This is good. This is good. Now we will check this point continuity with the positive terminal of the capacitor. It's good. Connect at negative terminal and bridge negative terminal. It is not making connection. That means this is the problem. It is making connection here, but this connection is not passing to inner side. I will make hole in this blank area to pass these voltage here. This is our negative line. And now I will pass a jumper from here to the second side to this negative terminal. Take care that there must not be any other track for any type of voltage. If there is a track, we can use insulation wire. DC voltage, $331. Now we can see when the capacitor is connected, now it is 331 volts. The ideal voltage must be 326 volts. If the capacitor is not in the circuit at that time, the average voltage will be 0.636, 207 volt. Our reading was 210 volt. That means the capacitor was out of circuit. If the capacitor is damaged, it is open inside or its tracks are open, its circuit is not complete, we will receive this average voltage because capacitor is not holding the voltage from this volt and above. This is the duty of capacitor. Now let's check voltage on the optocoupler. Input side, no voltage. Ground at pin number 2, that is VCC pin, no voltage. That means this IC is not working. Wait until it is discharged. Now we need to remove this IC. We received voltage at this capacitor and this IC is not taking start. If this IC is good, it will take start, it will switch, because there are no additional components for oscillation, switching, anything. When we have voltage here, it must start switching, because its startup circuit is internally connected to pin number 2. Either we don't have voltage here or any place. If this IC is not starting, that means this IC is bad. Check resistance of the transformer winding between positive point of the capacitor and these 5, 6, 7, 8 number pins. These are connected. That means we don't have any problem with transformer. I removed this IC from the board, STR3A155D. It is not available in the market. It is 67 kilohertz. Working voltage range 7 volt to 15 volt. This is its working voltage. Now I have two options. I have to wait for this IC, or we can replace with the same switching frequency. The one option we have 3BR1065. It is also 65 kilohertz, but its working voltage are higher than this one. If we install this one, in some circuits maybe it will work, and in some circuits maybe it will not work. Why? If the auxiliary winding voltage are less than its required voltage, at that time it will work in reboot mode. Its VCC requirement will not be fulfilled by this transformer auxiliary winding. For that purpose we have another option. We can use top 249 Y IC. Basically this IC is 132 kilohertz, but this IC have option if pin number 5 is connected to control pin, VCC pin. At that time it will start to switch at half frequency here. That will 66 kilohertz. Our required frequency is 67 kilohertz, but this will work in 66. That is approximately closer value, and it has jitter frequency, so that its range will exactly fit with this IC. Now the second option, we need 5 volt to 6 volt working voltage. In this IC we have 8 volt. When we are using top 249, at that time the control voltage are passed through optocoupler. VCC winding, bias winding, this will go to control pin. We can drop the voltage by adding some resistance here. It is doable. In this IC, optocoupler is connected, emitter is connected to ground, and collector is connected to feedback pin. We need to convert this circuit in this shape. It will work. How we can change the pin configuration? In this IC, the rightmost pin, that is drain pin number 7 will go to 5, 6, 7, 8. This is 3A155, and here we have top 249Y. Then there is pin number 5. 5 will be connected to pin number 1. So these two pins will connected to this one. These will connected to optocoupler emitter. And here is VCC capacitor. External current limit, line sense, source pin. These three pins will connected to ground. We will disable line sense and external current limit. So this will work in 3-pin operation. Source is grounded. These two pins will go to optocoupler. Here we will rearrange the optocoupler in this configuration. And we can also replace 3BR 1065 with this one. In this IC, pin number 1 will go to 5, 6, 7, 8. Pin 2, current sense, will go to current sense here. That is pin number 1. Then pin number 3 BA, we will leave it open. Then VCC here, that is pin number 4. This pin number 4 in this IC here will go to pin number 2. Then ground. 5 will go to pin number 3. Then feedback. 6 will go to 4. If the VCC voltage can be maintained at the same limit at that time, this IC will work. In first step, we will try to use this 3BR 1065 and we will see the result. If you want to use this one, its pin 1 is drain pin. It will go to 5, 6, 7, 8. Drain here. Now we will align other pins. We will leave pin number 3. 1, 2, 3. This will go to pin number 1, 2, 3, 4. Okay, all pins are now in one sequence. Pin 1 is at 5, 6, 7, 8. Pin 2 at location number 1, 3 blank, 4 at pin number 2, 5 at pin number 3 and 6 at pin number 2. It is fluctuating. That means the IC started working. If you will check VCC pin number 2, it have fluctuation. Now the circuit started switching. That means this IC started working, but it have some problem. Let's monitor the secondary side. These capacitors. If we check its outputs, it have one output, 2, 3, 4. 4 diodes, 4 outputs. First output, second, third, fourth. Always take care for the safety. Now let's check voltage on these capacitors. 12 volt, 20 volt. This capacitor is not receiving voltage. Then this capacitor, 5 volt are reaching here. We have problem in this circuit. This capacitor is good. Yes, we can see this rectifier is dry soldered. This rectifier is separated from the circuit. This is the problem. I resoldered the diode and installed back the capacitor, and now let's check voltage. DC voltage. Yes, that's nice. Still we have fluctuation. Now to overcome this fluctuation, we have one idea, that here is a small resistor that is between this cathode and this capacitor. We can bypass this resistor, the small resistor here. It is 18 ohm resistor. We will remove it. Just for practice, we can make a jumper from cathode to capacitor to bypass this resistor. Might be it will bring the voltage within this IC's required limits. If it will not work, then we need to switch to this IC. Then we will increase this resistance. Now we are decreasing this resistance to increase the voltage for our required limit. Now I will connect jumper directly from cathode to the capacitor positive terminal to bypass this resistor. Here in the actual circuit, when I am using this one, I connected a jumper from here to here to bypass this resistor instead of removing. Now we will see the result. DC voltage, check voltage at the LED side of this optocoupler. Yes, it is stable. Now we will check the VCC voltage. Yes, now it is stable. Because when the IC is starting in soft start, it needs to detect 17 volt minimum level, that is threshold. After that, this IC will switch into smooth working operation. Now we will check other voltage. Always take care for safety. Voltage on this capacitor 12.71. Exactly 20 volt supply ठीक है. Now this capacitor have 21 volt. It is 20 volt supply, that's nice. These 12.7 volt, these will reach here 12 volt. And then we have this capacitor 21 volt stable, that's nice. And then we have 15 volt, nice. Now all voltage are stable. 7.8 volt, 7.8, 7.8. Yes, now this 5 volt must be absent until this IC will receive turn on command, that is power on command, standby voltage here. When this IC will turn on, it will provide voltage here at this capacitor. Then it will go to this 5 volt regulator. This 5 volt regulated 5 volt will go to the next circuit, microcontroller and everything. So our power supply section is now recovered. In this way we can take approach by replacing IC. If you enjoyed this video, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.